Institute under Osmania University, Hyderabad. And he was postdoctoral fellow in Cambridge University as well as Rice University. So he spent time as chief scientist and head of the seismic group at NGRI. And I think he spent significant time of his career at NGRI Hyderabad. He is currently the director of Wadia Institute of Himalayan Geology, which is another autonomous institute of DST like Bose Center. His expertise is vast. He includes machine learning, seismic tomography, full waveform inversion, attribute characterization, rock physics modeling, etc. And he has got various awards and accolades. He is a fellow of all three Indian science academies, as well as he is fellow of the Andhra Pradesh Academy of Sciences and Telangana Academy of Sciences. He is recipient of J.C. Bose National Fellowship, National Merit Scholarship by Ministry of Education, Raman Fellowship of CSIR, and Boy Scouts Fellowship of DST. And he has been honored with Distinguished Alumnus Award of RSM, AP Scientist Award, National Award of Excellence, and the list is long. So, and he is currently, this is important, he is also the Vice President of the Indian Geophysical Union, IGU. And with this, I welcome today's speaker, and we are eagerly looking forward to his seminar, because as you all know, there is lot of excitation, especially in the context of geosimot episode. So, Professor Sain, the stage is yours.
Am I audible to everybody, those who are online? And first of all, I thank Madam Professor Tanushree Dasgupta ji for invitation, and I feel honored to deliver this talk at Bose Colloquium lecture. I have chosen a topic, something different from the researcher and the faculty members have been pursuing at Bose Institute. Basically, I'm from an institute which is looking after some sort of issues related to geodynamics of the Himalaya, geo-hazards of the Himalaya, geo-resources of the Himalaya, climate-tectonic interaction. And I will just touch upon some of the aspects which today you must have seen in newspaper, you must have seen on the TV, lot of discussion is going on about the fragility of the Himalaya, about different sorts of geohazards. But what are the main causes behind these, and what are the plausible mitigation as a geoscientist we can provide so that we can build a very safe and secured Himalayan states. There are 11 states into the Himalaya. There are 2 union territories. Each and every state and union territory has specific geological situation, structural configuration. They have different sorts of geohazards. And let us see some of the important aspects, what I can cover within next 45 minutes, like that. So let us see, when we're talking about Himalaya, how the Himalaya has been evolved into the past. This is the particular slide which can give you an idea about the formation and evolution of the Himalaya. All of us know that the Himalaya has been evolved or formed by the collision tectonics between the Indian plate converging beneath the Eurasian plate. And that started in the early Eocene time. And we have been experiencing that because of this convergence or collision between two plates, there have been a lot of material. You can see they are getting scrapped and stacked over that, and that has formed the mighty Himalaya, that is 2,500-kilometer long stretch from northwest to northeast, from the Nanga Parbat to Namche Barwa in Arunachal Pradesh, and it has roughly 250, 300 kilometer, 350 kilometer, depending on different parts, the width. And the Himalaya has been formed like this, and we can see some of the important geological and tectonic elements that have divided the Himalaya from south to north into different parts. We call the first part above the Himalayan frontal thrust, we called Gangetic Plain, Indo-Gangetic Plain. Then there is another geological tectonic element we call main boundary thrust. And in between main boundary thrust and Himalayan frontal thrust, we have the sub-Himalaya. And then main boundary thrust and the main central thrust, we have the lesser Himalaya. And towards north, further north, between MCT, main central thrust, and Southern Tibetan detachment, we have the higher Himalaya. Beyond that, we have Tethys Himalaya and the Tibetan plate. So what exactly has happened by the collision between this Indian plate and the Eurasian plate, or maybe in this northern part, the Tibetan plate, a lot of subsurface phenomena has taken place, and because of that, Himalaya is fully stressed. And I'll come back to that. So that was the long stretch, and now I am showing the south to north one section, cross section, and we have seen all these elements, MBT, MCT, STD, and they have different type of landscapes, different type of geomorphology into the Himalaya, sub-Himalaya, lesser Himalaya, higher Himalaya, Tethian Himalaya, like that. And
are we allowed to ask in the question?
you can note down all in your mind. At the end, we'll take up all the questions. And then this is obvious that this mountain is the world's youngest mountain range, and which has a very rough terrain into this situation. And I have told that has been formed by the collision tectonics. And the Himalaya has a lot of resources: high Himalaya glaciers, snowfields, springs. Springs can be hot springs, cold springs. There will be varieties of minerals and ore bodies, particularly into the Himalayan high pressure and high temperature regime. It is a peculiar situation or environment for the formation of some peculiar or some different type of minerals and ore bodies which can be found, as well as we have a lot of hydrocarbons. Because of the Tethyan Sea, you know that Indian plate was moving, Eurasian plate was here. In between, before the collision took place between the two continents, two plates, there was Tethyan Sea, and there was subduction of the Tethyan Sea. Lot of materials in the organic materials. There are a lot of fossils into the Himalaya. There are a lot of organic rich material. It thrust off and into the higher Himalayan region, into the sub-Himalayan region, lesser Himalayan region. There are a lot of basins which are conducive for the formation or accumulation of the hydrocarbons. So these things are there, and we have seen a lot of mighty rivers have originated from the Himalaya, and the sediment water transmits, and all these resources have made Himalaya as a center stage for the habitation, for the socio-economic, agroeconomic, cultural growth into the Himalaya. And a lot of people are settled into the Himalaya, different parts. So I have talked about that because of this collision, the convergence between Indian plate and Eurasian plate, the Himalaya is stressed. A lot of subsurface processes are still going on. That subsurface processes are exhumation or rising of the material, tectonics, neotectonics. Then we have talked about deformation of the rocks. When there is a convergence, rock is getting deformed, rock is getting strained because stress have been accumulated into the subsurface. And all these things, besides that, there are a lot of surface phenomena, that erosion, weathering, and some sort of precipitation. The precipitation can be liquid precipitation in the form of rain, as well as high altitude solid precipitation in the form of snow. So these things are happening. And in the present climate change scenario, we have seen there have been excessive rainfall that are leading to flash floods. There have been excessive snowfall that are leading to avalanches into the Himalaya. Further, the stress have been aggravated because of these anthropogenic activities. Lot of developmental activities for the road construction, ropeway construction, tunnel constructions, buildings, different type of infrastructures are loaded on the surface of the Himalaya. This is one thing. And second thing, what I am telling, that in the past 2 to 3 decades, there have been excessive climate change events, either excessive rainfall or excessive snowfall. So all these things are still going on. Himalaya is still rising, as well as Himalaya is also getting eroded by different sort of processes. So the process, what we have talked about, subsurface, surface, and then aggravated by anthropogenic activities, aggravated by climate-induced phenomena, all are going on. And that's why Himalaya is very, very fragile. So at one hand, we see that Himalayan environment is fragile. Second hand, we see that a lot of resources are there into the Himalaya, and a lot of people are habitated into this Himalayan long stage of the Himalaya, 2,500 kilometer long stage east-west or northwest, southeast, and 250 to 300 kilometer width into this Himalayan region. And these processes are making some sort of changes into the geomorphology as well as landscape of the Himalaya. And we have also seen, because of all these processes, Himalaya is experiencing a lot of hazards, geo-hazards, we call it, either by avalanches or by landslides or by earthquakes or glacial lake outburst floods, flash floods. A lot of things are happening. And these phenomena causes some sort of damage either to the properties or structures or to the lives and livestock. The pattern of damage depends on how the landscape and geomorphological features we observe and what are the subsurface and subsurface processes are controlling to the changes into the landscapes. So all these things are there. So it is very, very complicated. And in the Himalayan region, every year we are experiencing some sort of hazards, some sort of catastrophe, some sort of disasters caused either of these phenomena, whatever I described, either by earthquake or by landslides or by avalanches or by glacial lake outburst floods, flash floods, etc. And prime ministers have given a strong indication that we have to mitigate those measures. Disaster risk reduction, DRR, out of 10-point agenda, disaster risk reduction, and the geohazards into the Himalayan region, how will be able to comprehend all the processes and give some sort of measures so that we can give some sort of mitigation into that region and build a disaster-free as well as climate adaptable future, not only for our generation, but for our next generation, for the sustainable growth and development into the Himalayan region, to have a very secured and safe place for living into the Himalayan states. So at one hand, I told a lot of resources are there. And if we do not excavate all this energy, all these resources, different forms of resources are there, then we'll be able to disturb the Himalayan ecology, we'll be able to disturb the Himalayan biodiversity as well as the ecosystem. So we have to manage our societal, cultural, economic, agricultural growth by doing in a scientific way so that it will not impact too much to the vulnerability, to the fragility of the Himalayan region. So we have a very, very important role. How will we be able to make a balance between the economy by exploiting the resources, as well as we'll be able to do some development, because a lot of things are happening into that regions. So, and we are talking about climate change. That's what I have chosen this topic. And if you talk about climate change, there are many people that believe into the climate change. They do not believe, but we have a lot of evidences of the climate change. And in Himalayan perspective, if we look into the what are the indicators of the climate change, then definitely you have seen, I'll also show some of the slides, that high altitude glaciers are shrinking. Glacial lakes are being formed, being expanded. And if you look into the thickness of the ice cover into this into the high altitude, that also getting variability. So a lot of things we can observe into that region, as well as there have been upward shift of the tree line. So these are the direct indicator in Himalayan perspective, the changes of the climate taking place, and these are the indicators. And it is having a lot of impacts Impact, since we know that impact in the terms of the water scarcity, we are experiencing water scarcity. They're also having some sort of impact to our energy security, food security, health security, and the Himalayan ecosystem biodiversity is also getting affected. And all these phenomena are indication of the impact of the climate change. And we are also experiencing there is land degradation, there have been some sort of landslides, avalanches. So today I will touch upon some of the important aspects of these three. The glacial lake hazards will comprehend what are those hazards and how we'll be able to give some sort of mitigation measure by doing early warning system. Second important thing, I'll be showing the concept of the landslide hazard, and then I'll be providing some sort of mitigation measures. And third, we'll be showing that a lot of flash floods are taking place because of this excessive rainfall, because of the excessive snowfall into the Himalayan region. I'll be able to give some sort of mitigation measure into that direction. First, let us talk about the glaciers and glacier lakes related hazards and its plausible mitigation in terms of it. So already we talked about that into the high altitude, there are a lot of glaciers, then there are snow, and the snowfields are glaciers. They're feeding a lot of mighty rivers, and they are the lifeline to billions of people for irrigation, for drinking water, for domestic usage, for industrial usage, as well as hydroelectric power generation. So a lot of implications are there into the watershed of the Himalayan region, number one. Number two, that water and sediments, they are making the land fertile, and these have made attraction as a center stage for habitation, agroeconomic, cultural development into that regions. But if you look into the entire Himalayan region, more than 10,000 glaciers are there, more than 20,000 glacier lakes are there into the Indian Himalayan region. We are not talking about other part of the Himalaya, which is other side. Indian Himalayan region, so many glaciers and so many glacier lakes are there, and it has covered glaciarized basins of around 37,500 square kilometer area. But glaciers are having a lot of implication in terms of social, in terms of economic, in terms of cultural, in terms of in our agricultural point of view. But these glaciers and glacial lakes, what we define, they pose threat to the people living into the downstream, whether to the structure, whether to the properties, whether to the people, whether to the livestock, many other things that is happening. And if you look into one example, I am giving only from Uttarakhand point of view, that 2013 Kedarnath disaster that took place. And basically, the Kedarnath disaster was caused by glacial lake outburst flood. And there was some sort of incessant rainfall. And there was some sort of moraine failure, as well as that killed 6,000 people, inundated 5,500 villages, and trapped 2 lakhs pilgrims. In the Uttarakhand region, every year, lakhs and people, they visit for their pilgrimage purposes. So when it happened, it got massacred in the form of all these whatever talked about. Then before last year, 2021 February, so this happened into summer, June. But in 2021 February, again in Dhaliganga, Rishiganga, we found the huge rock and ice mass from a 5,600 meter above mean sea level fell down to 3,600 meter Gonthi Gadi floor. And when it fell down in February, because of this impact, that ice got melted, fragmented, and they created a lot of slurry material. And the high altitude, that slurry material, when it came down, along with that en route, is also found out lot of sediments, lot of water pockets, as well as small plants, whatever existed into its way. And momentum increased as it went down and down. And then got the devastations, breaking the bridges, breaking the roads, disconnecting the villages, as well as it made impact to the Rainy village. There is a hydroelectric power project, Tapobon hydroelectric power project. It's cost there was 200 people killed. So it can happen anytime. It can happen summer, it can happen winter. We have got this type of examples. And if you go to the hydroelectric power project, then you see whatever the path for the and water are there. Along with the water discharge, there have been sediment discharge have been increased. And the sediment discharge increase in sediment discharge has been a concern to the stakeholders of the hydroelectric power project, because they are now getting silted into the reservoir, And if it gets silted into the reservoir, the dam is constructed based on certain pressure exerted by water column. But if there are siltation into the reservoir, the pressure exerted will be by the sediments, and that pressure will be much more, so the dam can be breached, number one. Number two, that particular sediments, when they go down, they can corrode the turbine blade. The life of the blade can also be reduced. So they are much more concerned to know what are the sediment flags, how we'll be able to do some sort of modeling. That modeling can be done based on mass movement modeling or debris flow simulation into the lab. So we have a lot of opportunities, we have a lot of scopes to understand and comprehend the processes and give some sort of suggestions, give some sort of understanding into that area, so that stakeholder can take care about their projects into the regions. So we are talking about glaciers, we are talking about glacier lakes, but for the benefit of many researchers, many students, those who are not in this field, what is glacier? Glacier is nothing but a big mass of ice formed by compaction and recrystallization, and it can move also slowly because of its gravitational force, gravitational attraction, and in that way you can see this is the glaciers. And what is glacial lake? Any lake that has been formed by the glacial activity is called glacial lake. You can see this is the glacial lake, has been formed by the glacial activity, and mostly lakes are formed in the front of the glacier, but it can be formed on either side of the glacier, even over the glaciers, below the glaciers. So we have got different nomenclature of the glaciers depending on its nature of formations. The glacial lake, and once that ice melt because of this climate change, these lakes are expanded, the new lakes are being formed, and they are the concern because they are all in the depression into the high altitude. When anything is there because of its potential, there is every chance of breaching that lake at the high altitude and may cause devastation into the downstream, where maybe some sort of structure, maybe some sort of lives, habitation, culture, different type of things are there. They may cause damage to those. So we are showing the concerns. Just I will give the example how the glacier lake outburst flood takes place, how the glacier melt aggravate that type of glacier lake outburst flood we call GLOF. This is, let us take one of the lake that has been formed into the high altitude, and there has been every chance. And when we talk about high altitude, they are seismically very active zone, because the seismic zone 4 and 5, because high convergence, lot of subsurface energy is accumulated, and that energy gets released in the form of earthquakes through that. So they are seismically very active into the region. So if there is some sort of glacial lakes at the high altitude, there is every chance there will be some sort of tectonic forces. There will be some sort of landslides, you can see. There can be ice avalanche. There can be some sort of precipitation. And there can be some sort of ice melt from the glaciers. They all can contribute to this glacial lake. And in turn, the lake cannot sustain that, and which will happen in the wall can be breached or lake can be overflown. And if it takes place at the high altitude, again I'm telling, then there will be some chances of devastation of flash floods into the downstream. That is the concept of the glacial lake outburst flood. That is the concept of the ice melt, what exactly happening into the high altitude, and why we are showing concern, because this may cause devastation, this may cause catastrophe, disaster into the downstream. So this is one of the example I am just showing. Like that, I told in the beginning, there are 10,000 glaciers, 20,000 glacial lakes. Each and every lake and glacier may not cause threat, but we need to understand from the satellite data, from the remote sensing data, which lakes may pose threat, what are the sizes of the lakes, and what are the ice melt rate or glaciers retreating rate. So if we can understand all these phenomena, this helps us to monitor the health of the glaciers, health of the glacial lakes, which in turn help us to defend or to provide some sort of mitigation measures into the downstream. So this is the very fundamental thing and concept we understand. So what I am telling that if we monitor, I will tell how monitoring helps us to know the health of the glaciers as well as the glacial lake. Just take one of the example from the Sikkim Himalaya. Our researchers have done this works. You see, this was the glacier 1991, 2000, and 2015. Can you see there have been shrinkage of the glaciers, and the glaciers, the melt water is getting accumulated into the lake. Can you see the expansion of the lake? So these are the concerns. If we continuously monitor, we'll be able to understand what exactly going to happen to the lake, what is happening to the glaciers. So monitoring of the glaciers, monitoring of the glacial lakes is very, very important to forward, to know what exactly happening to them, and accordingly we can take care people, structure, properties into the downstream, because this will, there not many habitation is there. Habitation is there, structures are there in the downstream. So if we can understand all these phenomena in the happening into the upstream, it will help us to understand what exactly it may impact to the downstream. Like that, one more example is also shown over here. You can see how this has been expanded over a time, and this has been reduced in the size. I told that 2013 that Kedarnath Glacier Lake burst flat, that caused that sort of devastations. But there are not only one instrument which will be utilized for the monitoring. For monitoring, several sets of network is required. We have to look into hydrological data, meteorological data, ground penetrating radar system, geotechnical investigation, lake bathymetry. We should know what is the configuration of the lake over time, volume estimation, inventory, and transmission and analysis of the data. And then all these things, if we want to understand in real time, we have to introduce the artificial intelligence and machine learning, because human intervention has to be reduced. Human cannot do 24/7 hours job. So to reduce the intervention of the human analyst, we have to take the help of the artificial intelligence and machine learning. And you can see what exactly happened after the disaster, and this was the pre-disaster. This was the lake I was talking about, the glacial lake, which outburst. That's why it is called glacial lake outburst flood and block. That was the June 2013. I'm now giving another example that 2021 February, what happened into the Dhaliganga, Rishiganga, that ice rock avalanche, and 27 million cubic meter volume of ice and rock together fell down from that 5,600 meter to 3,600 meter. And I explained what exactly happened. And when it fell down, that is the point we call initiation of the avalanche. From the initiation of the avalanche, fragmentation, and its impact to the road, impact to the bridges, impact to the hydroelectric power stations, killing to the people, all these things. We have a nearby seismic station into the top of one, and we have identified the impact of each and every, starting from the nucleus or avalanche site of the particular rock mass to the damaging site. Every event has been recorded into the seismometer only at the nearby seismic station, not at a very far stations. And we have reported that all the events, we have given the name T1, T2, T3, T4, T5. These are available into the science paper we have published, as well as scientific reports. And there we have seen each and every point of the impact of the avalanche onto the seismometer. Besides that, what we have got, that mostly we are monitoring. We told that glaciers, lake outburst flood, or glacier, the disasters are generally caused by multiple factors. We mentioned into that recession, that means sinking of the glaciers. There can be lithology, the structures, that particular lake. If the mostly the lake in the high altitude are formed by the very loose debris material, they are of the called moraine, etc. And that the climate variability, as well as moraine failure, rainfall, and glacial lakes. And all these phenomena till date we have been monitoring using hydrological data. Hydrological data, for that we can understand what is the glacial recession, what is the mass balance, what is the sediment and water discharge into that regions. And this can be done using automatic water level recorder. As well as we are depending on the meteorological data. We want to know what is the variation into the temperature, what is the humidity, what is the wind speed, what is the wind direction. And if we have automatic weather level, weather stations into the region, this gives us a lot of information. So to monitor the lakes, glacial lakes and glaciers, we have been heavily dependent on the hydrological data and the meteorological data. But after the 2021 glacier and ice mass avalanche from the Rontigrad flow, we have established that before the main event took place, there have been a lot of microtremors that existed for 2 to 3 hours. And these microtremors are nothing but, these are the precursory events for that main event. So before the main event took place, there have been a lot of precursory events, and that gives signal that something is envisaged. So you have to be careful. So we have given some sort of suggestions that instead of having the network, only the hydrological stations and the meteorological stations, if we can establish the seismic stations, that will also help us. And all the data from a particular catchment, from a glaciarized basin, are transferred to the centralized basins, what we have at a centralized processing center, analysis center, Wadia Institute, Himalayan Geology, real time. And if we want to have the real time, you can do either by mobile, or you can have some sort of VSAT, GSM, all these things. And then once the data comes, we have to feed into the system. And all these processes can be integrated using artificial intelligence and machine learning by 24/7. And we give a threshold. Once it exceeds the threshold, it gives alert system, it gives warning. So we can tell the nearby people and the local authority administration that something into that region is envisaged. We have observed that alerts, and that alert helps them people for evacuation, even to take care by the administrative people into that regions. So as a whole, we have also understood there are so many glaciers, so many glacial lakes. So we cannot monitor each and every, but we should look into that particular glaciarized basin, which has a lot of important structure, lot of habitation into the downstream. So we have chosen that Rishiganga, Daliganga basin, as well as some of the Bhagirathi basins, which we should monitor. And once we have developed that early warning system into the region and integrating all the data sets, similar things can be developed elsewhere. I'll be giving one example into that Rishiganga, Daliganga, that till date in that Reni village, this is the Reni village, into the remote sensing and satellite data, we have observed subsidence. And this subsidence is an indication that region may experience some sort of landslide into this region, and the probable cause into the Rishiganga, that the flow of the mud, flow of the debris, flow of the water was so huge that it was toe cutting. Toe cutting means in a slope region at the bottom, because when water flows through that, it cuts. And when it cuts, there is a vacuum, and it's because of its load, it gets subsided. And that is a concern of the unstable slope, and that can lead to landslides. So we are still monitoring into the post-mortem data into that region, and we are also understanding what I showed into the first few slides, that there have been concern by the stakeholders that there will be a lot of sediments along with the water that may cause erosion to the turbine blade, that may cause siltation to the reservoir, which will have some sort of impact. So we are also doing some sort of mass movement modeling and debris flow simulation, so that we can understand all these processes into this region, at what rate, what type of particles are flowing, and what are the probable cause of the unstable slope or leading to some landslides into this region. We are also looking into high resolution satellite data, drone-based survey into the region, so that we can understand that DEM generation. You can elevation modeling, you can do differential elevation modeling, you can do. So as a whole, if we have in a glaciarized basin a system of hydrological data, system of meteorological data, system of seismological data, as well as there is an opportunity to go to the field ground-based data and satellite and remote sensing data, INSAR data, etc. All this data independently can give you a lot of information about the health of the glaciers, about the health of the glacial lakes. And if we can integrate all of them using artificial intelligence, we'll be able to develop the integrated warning system. And once it is established in a particular glaciarized basin, similarly, it can be deployed. It can be developed and deployed in other basins. And entire Himalayan region can be saved in terms of giving some sort of early warning. That's what I told in the first slides, that we have a responsibility to build a disaster resilient, a climate adaptable future for sustainable development into that region. And this is the only way we can do, by having all sorts of data together and then integrate and give some sort of alert system into that region. So this is about the glaciers, glacial lake related hazards, and what are the way forward for their mitigation. Then I will jump to the second important topic, landslides, and it is very, very peculiar into the hilly states, hilly region, as well as into the hilly towns. And today you have seen into the news, Yoshima, like that many other places in the Himalayan states, we may experience all these things. So why we are so much concerned about this? Because if you look into the landslides in the world scenario, then you can see around 30% of the landslides occur into the Himalaya. About world's landslides picture, and that landslides are occur due to different processes. It can be natural processes, it can be some sort of degradation, environmental related, it can be anthropogenic activity, it can be due to the increased urbanization into the region. And during the last 1 decade, you have seen the frequency and magnitude of the landslides have been increased, particularly in the Himalayan state like Uttarakhand, and next is Himachal Pradesh. Every year we are experiencing some sort of heavy rainfall. Sometimes it is defined as the cloud burst. There is a difference between heavy rainfall and cloud burst, simply for the sake of that. When it is more than 100 millimeter per hour rain, we define as a cloud burst. Less than is heavy rainfall, but much less is not considered, but 180 millimeter per. So heavily within a short period of time, so much rain, they are not able to flash out immediately. They are causing some sort of flash floods. They are getting just, and there are some sort of constriction of the structures, just like in Bangalore also, that heavy rainfall, because the drainage pattern is not proper. If there is a sudden rainfall for a limited time, it cannot be drained out, because the system do not have that. And some of the lakes also have been encroached. The lake also cannot hold that much of water, what it was supposed to hold along that. So there are a lot of reasons we have created man-made anthropogenic activities. So we have to look into all those aspects in the present climate change scenario. So if we look into that, then some of the prominent disasters, if we look into the Uttarakhand state, then you can see 1998, Pithoragarh, there was a huge landslides. We pay heavily for that landslides. 2003, Bornaba landslides, and 2012, Chamoli landslides. Besides that, there are other tragic landslides happening to the Uttarakhand state. Is the Kaliasur in Alaknanda, and the Malpa in the Kali Valley, Natala in Bhagirathi Valley, as well as Balianala in Nainital town. You can see if you have gone to the Nainital, you can see a lot of slopes. Into the slopes, lot of structures are there. So there is some sort of exertion of the pressure, exertion of the load. So we need to understand how much it can sustain, how much it can withstand in the regions. So these are the impact of the landslides. You can see that because of these landslides, one of the example I'm showing over 2019 August Uttarkasi landslides, because of this extreme rainfall, and you can see many things are stuck into that region and fell down, all sort of things. So when we talk about landslides, what are the way forward? How do we know which part of the town is more vulnerable, susceptible, risk involved compared to the landslides, with reference to the landslides? So for that, if we look into the slopy town, slopy Himalayan regions, then you can see slopes, in which angle slope is like this, slope is like this, so it is gentler. Or you can see the direction of the slope, asperity of the slope. You can also see the structure of the slope, lithology, rock strength, how the land has been used into that region, what are the vegetation cover, that forest cover, all these things, built up area, how the weathering has taken place. So if you look into all these parameters, again, by using all these parameters based on artificial intelligence, machine learning, you can prepare the landslide risk map. So this is one of the map we have prepared for the Mussoorie town. And if you look into the risk map, then you can see red is the very high risk zone and green is the very low risk zone. And if we have this type of risk map, susceptibility map, vulnerability map, this helps to the city planners, city developers to build the smart towns, to build the smart or green corridors. What type of land you should be used, this high susceptible zone land should be used for what purposes, low susceptible zone should be used for what purposes. So the land use map can be prepared based on this high susceptible, medium susceptible, and low susceptible maps. So this map is very, very important. And from this map, we cannot say that high susceptible zone, definitely high susceptible zone means this will be susceptible to the landslides. And this is the least susceptible, low susceptibility to the landslides. But problem comes that landslide from this map, immediately you will not be able to predict. To forewarn the landslides, we have to look into 3 or 4 more important factors which trigger the landslides. So which are the triggering mechanism, triggering factors for the landslides? They are nothing but the rainfall. one of the things. And you know that in high altitude, and we have experienced in seismic zone 4 and 5, there have been tectonic movement, earthquake. So if there is some sort of tectonic forces, if there are some sort of heavy drawdown of water from the underground, then our heavy load on the surface by human intrusion. So there are 4 important factors. If we can add, then either of these can trigger the landslides. So we need to, so I am showing some more figures into the local scale, Nainital town, Bhagirathi Valley, and Goriganga. So what we have to do for the forewarning of the landslides, we have to place some sort of wave-based sensors. The sensor can be inclinometer, can be piezoelectric, there can be a rain gauge, can be insert, can be total station, extensometer. So if you can place all those places, red zone area, all the sensors, and the sensor data, if you analyze and process into the headquarter, and then if you can couple between the slope instability, we have shown that red zone is much more slope instability, and the couple between the threshold of the rainfall, threshold of the tectonic movement, threshold of the human intrusion, or threshold of the groundwater drawdown, you will be forewarn the landslide into these regions. Out of all these triggering factors, the rainfall is the most culprit, which is causing so many landslides into the Himalayan region. What I told, the 30% of the world landslides occur into the Himalayan region. Only rainfall and excessive rainfall in the present last one decade is much more effective than any other factors. And this, once we have, then we can also do some sort of measures for the mitigation. And towards the mitigation of the measures, we can have 2 types of approaches. One is structural approach, one is the non-structural approach. In the non-structural approach, so whenever you know that this part is more susceptible to landslides, so your buildings should be limited, floors should be limited, construction materials should be defined that they can sustain that landslide. And most important thing, that you should not expose any structure to that zone. So this is one of the major non-structural. In the structural, if we find that region is high susceptible, then we can have some sort of wire mesh. We did from Wadia Institute, we had a very success story into the Bornavat Parvat, where we had all this type of wire mesh as well as some sort of structure wall you can do. You can have some sort of nails, shotcrete, and soil nets, rope bonds to protect the slope movement. The slope you can arrest by creating some sort of structure. They are called structural measure, and another one non-structural measure, by giving some sort of building codes, by allowing some sort of structures, by not allowing exposure to that region. So there are some sort of measures we can have, and we can monitor into that region by all those wave-based sensors, what I defined into the previous slides. This is second part. Third part, last part, is that during the last 1 decade or 2 decades, we have seen excessive rainfall, we have seen excessive snowfall, that leading to flash flood, that leading to avalanches into this region. Quickly, I will go through and show you some of the recent phenomena that have been affected by the extreme rainfall and extreme snowfall into the Himalayan regions, and then we'll provide what are the mitigation measures for that. So if you look into the Indian Himalayan region, so these are the different type of phenomena associated with the climate change: cloudburst, flash floods, landslides and debris flow, ice dam, the surge type, bluff, ice block avalanches. And with this height and elevation, we have shown all these phenomena. These have been listed over here. And I will just touch upon some of the things over here, that in 2022, Kedarnath, where a lot of pilgrims believe in the faith of their religion, and we have seen episodic some sort of avalanche, snow. They are getting avalanche. So in 2022, October, as well as some phenomena we have observed in November into that region, and we have given some sort of probable explanation of what are the causes of these avalanches. You can see all these things, and these have been, of course, published in last year, 2023, in Geological Geological Society of India. What are the probable causes of this episodic avalanche into the Kedarnath town? Number 1. Number 2, this also you have seen that September in Dharchula, Pithoragarh districts of Uttarakhand in the India-Nepal border, we have excessive rainfall, exceeded 100 millimeter per hour, and we call cloudburst. and cloudbursts elicited flash floods, and you can see this type of devastation and that things happen into this region. Here also, we have given some sort of explanation. Not only that rainfall, not only the snowfall, but what we have been doing, how we are occupying the places, how we are building the different type of constructions or making some sort of developmental activities. This all matter together, and that happened. If we are not prepared much, we will experience this type of phenomena into this region. What has been experienced by Kutila village in the Indian side, because Indian and Nepal, the border side, it happened. Third example, in Dehradun itself, in Maldevta, we have found suddenly there has been heavy rain, climate surprise. We didn't expect that. And in that slope region, that slope instability, lot of material just came down into the slope regions. And then the river flooded, a lot of people, and even some of the tourists, they were staying into the hotel, and the hotel also got flooded, and they are sleeping at night, and they lost their lives. And this sort of things happen, and we are not prepared. So what lessons we are learning from each and every event, that how we are explaining those events, and if we can understand all this in holistic way, we should build ourselves, we should give some sort of a precautionary measure and mitigation measure, so that next time if it happens like that, we'll be able to sustain. That is the message we are going to have. Fourth example, again in Amarnath Holy Clay, you can see in the Amarnath Holy Clay also there have been rain-triggered flash floods, and in that area also the drainage pattern was not correct. It was not able to flush out all the heavy rain. Then they didn't expect that type of rain will happen over there. And some buildings and constructions have taken place. They have made the construction of the drainage system, and because of that, not because of the heavy rainfall, but because of our way, anthropogenically, how we are prepared, how we have not understood properly, how we have not taken care, and that is the cause of this again rain-triggered flash flood in Amarnath Holy Clay. These are all last year phenomena I am showing. Listen, only 1 year, so many things. Five important things: Otulapuri avalanche in Hemkund side on April 1822, and you can see that they have the great fair. This much ice, this much snow, and there have been all these, and this has a route that we call that Otulapuri avalanche into that route from Ghangriya to Hemkund. There have been tremendous, and there have been impact, and some sort of avalanche of the ice, avalanche of the snow took place, and that. So we are suggesting that instead of going by foot, they should also have some sort of ropeway. Again, ropeway is also not very safe unless we understand what are the stability for the foundation, what are the rock type into the foundations. So we need to understand everything whenever we propose something to be done, to be carried out in a particular region, to avoid this type of disaster, catastrophe, or hazard into the high altitude town, into the high altitude, very important places into the Himalayan regions. And this is Baksuna in the McLeod-Ganj, Himachal Pradesh. This also we have experienced some sort of natural. Again, there also we found out the same problem because of the rain. They couldn't be flushed out immediately because again there has been some sort of constrictions of the natural drainage systems. So what we can see that excessive rainfall, excessive snowfall because of the climate change are taking place parallelly to, if it happens, if we can predict well in advance, how we'll be able to manage them. If we are not taking care of that, we'll be facing this type of disasters. There is no other way. So these lessons we are learning from all these examples, that how we'll be preparing ourselves, how we'll be giving some sort of suggestions towards the mitigation, how we'll be building that area or developmental activities in a region depends on many factors, not only one factor. And Ishiganga, Deliganga, already I have spoken to that. And the reason of that, the cumulative effect of the weathering, we call freezing and thawing process, there have been crevasses, snowfall, all these things have taken place into these regions. And this also we have seen before the cloud burst into this Uttarakhasi, and after the cloud burst, you can see some sort of disasters. So, climate change, we are talking about today, but fundamental, and you are doing basic science. So our job is to know if we want to have some sort of mitigation against the climate change, we have to find out the root causes. So what are the root causes? Everybody knows the root causes is the emission of the carbon dioxide, methane, or NOx, SO2, the greenhouse gas emission, and mostly the gases are being emitted by the fossil fuels, use of the fossil fuels. There are some contributions coming from the biomass burning. You have, all of you heard from the Himachal, from the areas, forest fires. And then there are, again, you have must be doing, some of you are doing, their contribution is not that much compared to this most important factor. There have been aerosols, there have been metal dust, there have been some particulate matter into the atmosphere. You can do some sort of black carbon studies. Besides that, every city, wherever is getting developed, there have been urban heating. If you look into the heat map into Indian region, you see wherever city are there, the temperature is more, or some heating is more from that urban heating. So all these factors are contributing to the global warming, and global warming is the main factor for the climate change. When you talk about climate change, then global warming is a factor, then its impact, how the sea level is rising. But why you are much concerned about the sea level rising? But if sea level rise a few tens of centimeters like that, because of the glaciers are retreating and climate change phenomena is taking place, then the low-lying areas, there are so many billion of people, and there are so many important cities into the worldwide will be underwater. They will be submerged. So we are showing much more concern. So when we talk about climate change, we have to look, we have to see why we are much concerned, because their impact not only to the health hazard, not only to the food security, energy security, as well as our water security, as well as changing into the biodiversity ecosystem, there will be phenomenal change onto our life system. That means many important cities in the world will be submerged, and many people will be under stress into that flooded regions. So if we understand the root cause, then we'll be able to provide some sort of solutions. So we are talking that mostly the fossil fuels is the main culprit for the emanation of the greenhouse gas, mainly carbon dioxide. So how can we stop that? So for that, maybe we have to find out what's the remedial solution because energy is the driver of economic growth of any country. Without energy, no development, no economic growth. Our life is standstill. So we need energy. So if we are heavily dependent on fossil fuels, that can cause some of the global warming factor. Then what are the alternate way? The alternate way is that can we do or supply a reliable and affordable renewable energy or green energy? This is one way. Second way, that gradually, because till date we are heavily dependent on the fossil fuels. So if we cannot find out an alternate solution, we have to switch over slowly to the low carbon environment free energy supply. What are that? So we have to think of it as a physicist, as a chemist, we can think of in that direction. So if we look into the scenario in our country, then we can see that we produce only 30% of our requirement, and not only us, entire world is looking after some sort of development, some sort of I will say a particular breakthrough into the region of the green energy. But if you look into that sector, then we can see only 6% is hydroelectricity, 5% is renewable energy, and 4.5% in nuclear energy is only meeting the world energy requirement. 80% of the requirement till date is made by fossil fuels, which are nothing but the oil, then coal, and then natural gas. And oil is having 33.1% contribution, coal is having 27%, natural gas is in 24.2%. And as per the International Energy Agency 2021 report, it says that fossil fuels will continue for a few more decades because we have not been able to make any breakthrough into the green energy. And there are so many energy resources into the form of green energy as there, either solar or wind or some sort of hydrogen, geothermal, even nuclear, even some waste to energy. You can have some of the biomass into ethanol, or you can have EVs, electrical batteries, or you can have some sort of agricultural residue. So, and sometimes plastics, these are all waste. So you can make it aviation fuel. So there are several ways we are talking about to make a change or to make a breakthrough, to make some sort of renovation into that area of the green energy and renewable energy, but we have not been able to success. So we have a greater opportunity, greater scopes for all of us to contribute into that direction, so that we'll be able to mitigate the use of fossil fuels. And other important thing is that we have to explore hydrocarbons into the difficult areas like fourth phase, subvolcanics. I'll not talk about all these things, but as per this International Energy Agency report, as it says that it will stay for few more decades, then we are expecting this more carbon dioxide, more greenhouse gas will be emanated. So if it happens, then we are further vitiating the environment and climate change. So for that, if we can make a breakthrough into renewable energy, very fine. If we cannot make a breakthrough into the renewable energy, then we have to see how we'll be able to mitigate the carbon dioxide. And for that, best and efficient way is the carbon capture, utilization, sequestration is the way. And as a physicist, as a chemist, you can do tremendous contribution into that directions. First of all, how you can do that? The carbon dioxide sources are two. One is dynamic sources, transportation. One is static sources. You can have some sort of household, they will be producing carbon dioxide. You can have some sort of processing unit, they will be producing carbon dioxide. So from the dynamic sources, from the static sources, you have to capture the carbon dioxide efficiently by absorption, by hydration. You have to find out some innovative way. What are the best way you can capture the carbon dioxide from the static sources or from the dynamic sources? Then, can you do in situ use of that carbon dioxide instead of allowing them to be added to the atmosphere? For that, again, you have a choice that carbon dioxide can be converted into carbonates by doing some sort of chemical reactions. You are expert on that. And if you have the carbonates can be used for glass, for the pulp, even for the water purifications, and even for the petrochemicals. Many ways you can use the carbonate. Even for you can use the cement or clay material. So carbon dioxide can be converted into carbonate, and that carbonate has tremendous applications. Can you make it from the static sources in situ, capture it, convert it into carbon dioxide by chemical reactions? And the carbonate can be used for several domestic purposes, what I gave you an example. Second thing, another reaction you can do by which the carbon dioxide can be captured and converted into methanol and its derivative. And methanol and derivatives can be used in synthetic fabrics. You can have some sort of petrochemical, you have some sort of agro product or paint. Many things you can use as a product of the methanol and its derivative that can be again used for. So there is a tremendous scope for us to capture the carbon dioxide if you are not able to succeed into breakthrough on the green energy or renewable energy resources. At least this energy, use, capture, and use it. Third important thing, I will do this. Another thing is that geological sequestrations, the carbon dioxide you can capture and then you can sequester into some of the geological formations, the depleted oil and gas fields. But that deep coal seams, there can be subvolcanic sediments, there can be sub-oceanic sediments, which are the good hosts for the holding of the carbon dioxide, and million years carbon dioxide stay over there. So it doesn't get being added to the atmospheres and causing global warming. And some sort of heavy oil, if you want to produce from the field, then you flood the carbon dioxide into the region, and carbon dioxide will sit and that heavy oil will come out. So you can use for the enhanced oil recovery, as well as in the gas hydrates, which are present into the Indian Ocean. So huge amount, 10% recovery can meet our energy requirement for 100 years. So huge potential of energy of gas hydrate is there. So if you pump into the gas hydrate reservoir carbon dioxide by molecular substitution, the carbon dioxide hydrate will form, methane will be, there will be molecular substitution, molecular replacement of the methane by the carbon dioxide. So you can recover that methane. So methane can be used for our energy purposes. It is having only one carbon, least amount of, so cleanest hydrocarbon energy is methane. You can produce that for energy purposes, as well as carbon dioxide can be sequestered. So Mixed energy, I told we have to slowly move to the mixed energy. And in our country, India particularly, demographically or geographically located such a way that we have Himalaya to the north, we have long coastline into eastern western margin, we have abundant wind and sunshine, we have the coal-bearing gas-rich sedimentary sediments together, and agricultural dominated rural area, and the that industry-based ecosystem into the urban area. So India has different type of climate. In the south, we have that tropical temperature. In the north, we have we have some in the Himalaya, we have alpine temperature, and monsoon, most part it is covered. So we have different type of energy resources available in our country. We have snowfall, and availability of different energy resources with varying energy requirement offers India the slow moving transition where we can have low carbon emitted energy which will meet our requirement and which will not vitiate the environment. So development of the hybrid technology by combining one or two, particularly solar, wind, and the geothermal or ocean energy, is the best alternative to meet the energy security of the country. Just to finalize what we have talked about, we have dense coverage of the sensors, so we can do that early warning system. We have fast computing machine. We have artificial intelligence, machine learning. We have advanced modeling system. We have very good human resource experts. So because of all this, it is very possible, whatever I talked today, if we want to convert carbon dioxide into methanol, convert carbon dioxide into carbonate, or develop some sort of early warning system against the event, disastrous event into the Himalayan region, like avalanche, like a glacier lake outburst, we can do that. And if we can do that, that will give lot of implications in to the saving of the lives, property structures into the regions. And if we look into their development, maybe costly, it is not costly. If you look into the cost involved into the damage, cost involved into the loss of lives, they are much more than the cost what we have to spend towards the development of the integrated warning system. Thank you very much. I must acknowledge my students and colleagues, those who have worked in varied field of research, not only at Wadia Institute of Himalayan Geology, but also at my other earlier institute, CSR, National Geophysical Research Institute. Thank you very much for patiently listening to me. I'll take up some questions.
So the questions that you have.
Yeah, one light blue jacket. Yeah.
Okay.
Yeah.
I was just wondering how you distinguish the different types of the rocks or the formation you have.
Yes. So if you're not a geologist, so geologists go to the field, they'll be able to understand what type of rock it is. Number one, they will also collect samples. They will analyze. We have state-of-the-art analytical facilities laboratory. We call SAIF, Sophisticated Analytical Instrument Facility. SAIF we have. Based on that, we will be able to know what type of rock are existing in which part. Then by looking into structures also, you'll be able to know what type of structures existing into that region.
Maybe Amitabh.
Yeah. Thank you for a nice talk. So can you go back to this early warning system that you have?
That flowchart table?
Yes.
Okay.
The tremors.
For tremors one,
Yes.
I'll go back. You can ask me to stop.
Very early.
This one? Not this one.
Early.
This
Yeah.
one?
This one.
Okay.
Yeah. So I can see this is the Chamoli.
This is the Shiganga, Dhaliganga.
Right. So I see that the tremors are in the micrometer region, right? Around 2000 nanometers, right? And also 2000 to 10,000. So and also the time scale is only about 3 hours.
Yes.
So is that sufficiently early? I don't think so.
Yeah. You see, when it started, and if you look into that part, we
Right.
don't see anything. Just we see, but it is a post-mortem. We have understood now. Now we are going to look into this extensively. So what exactly happened? These 3 hours, you are very much kind. The 3 hours time is very, very good time for warning. I will tell the example. This phenomena, when it took place into the high altitude, even in Dehradun, And when it came to the damage, the top of one area, it took 20 minutes.
Yeah.
It took 20 minutes. And in the 20 minutes time, we are still looking into the video. People are telling it is coming. Still, we didn't give any warning system. So compared to 20 minutes, 3 hours time is quite big enough.
Yeah.
And in that time, if we can alert the people, local administration, because already this will be in place system. It is not that today you are going and sending. In place, already people will be told that we are having administrations and they will be given this warning and they will be able. So everything in the Himalayan region has to be in place. Otherwise, you cannot do. Then it is another important thing. You have to educate the people. You have to sensitize the people. If such sort of wording comes to you, you have to take action. Otherwise, it will not work. There are many things you have to incorporate into that. This is only scientific information we are providing. For effective utilization, again, your role, our role, or your role means public role, and the administration role will also be there to sensitize the people that if such of things is alerted, you have to respond to that.
I have another question. Okay. So the examples you gave were all surface events basically. But Himalaya, because it's a new mountain, there is also a lot of seismic and volcanic activity. Right? So what are the
There is no volcanic activity.
Jalamukhi and other places?
No volcanic activity. No volcanic activity is now only seismic activity will be
Seismic
there.
is there.
So seismic, again for that also we have placed some sort of seismometer, and you will be able to warn only when it takes place at a very, very large distance. I'll tell you the seismic point of view also. This is a very important question. That is generally destruction by earthquake or any other things does not take place of its own. It takes place only by the structures what we have into that region. And whenever there is an earthquake, there are two types of waves we can have into that. The first onset P wave, second onset S wave, and then the surface wave. Surface wave has very large magnitude. If you look into some of the seismogram, you can see that surface wave, and that is the damaging. And it comes later. So if an earthquake takes place at 100-kilometer distance, then the distance, the time between P and S wave, destructive wave, will be around, depending on distance, 15 seconds, 20 seconds. It's much, much less than what time we are observing 3 hours. And that also in Japan, like country, they have been able to get successful warning within 20 seconds, within 15 seconds. So if they can do, because they have been doing mock drilling every week, so they know the moment warning is given, they have to act accordingly. But in our country, that 20 seconds, 30 seconds, you are talking about even 3 hours time, surprising, but they are doing in 20 seconds, Japan and China. So they are doing some sort of mock drilling and doing. But those things is possible not for the evacuation. Those things are possible automatically when there is some sort of metro will be stopped. Automatically there is some sort of traffic light will be stopped. So everything will be, whenever you are in a motion, you are in a danger. But whenever you are in static conditions, your danger will be much reduced. So that type of prediction and alerting by earthquake is possible. But again, in our country, we have to be very, very careful how we'll be able to sensitize.
I think this discussion can move.
Yeah, any other thing you can?
I think
Let them ask other questions.
mindfulness has
Thank you, sir, so much for giving this other part of the story that we are thinking. We just won't see what is happening or other. We can know the exact thanks a lot for that. My question is about the, like what you told was is all about like, okay, if this is happening, this is kind of the warning which can be generated, which is important by the way. And what you mentioned about Japan, I have seen personally that, how quickly that message can be delivered and how people can go to the basics, like, to save their life. My question is about the why it is happening. Why are we really working on that end? Like, you give one example, like human interference. And
Why it is happening? Which it? Is it landslides? Is it avalanche? It is earthquake?
different.
they all have different reasoning, but
Different have different origin. I spoke.
yeah, somewhere or other they have been connected to like greenhouse gases.
So greenhouse gas is only the climate change.
Yeah.
Other phenomena is natural. That earthquake is nothing to do with the climate change. Okay. Landslide has some part because Climate change is making huge rainfall, and the rainfall is again triggering the landslide. So this has some implications. So all are different piece of work into the Himalaya, and it has different consequences, different causes. But, your question, could I answer?
No, I'll talk to you.
Okay.
Yeah, I will do it first. So among the your climate change, which have a greater impact on the like aerosols, black carbon, or among them, which are the most significant?
You see, whatever I showed over here, that is from geoscience point of view. I have not worked anything on the aerosol. I have not worked anything on the particulate matter. I have not anything into the atmospheric features. Atmospheric features I have not gone, and I don't have expertise, but I can tell because of some experience, because of many of you, the way general knowledge, that anything into that region, even if there is a cloud burst, even if there is a heavy rainfall, we also need to understand how that cloud burst, why it is happening there, why not elsewhere, why another places is getting drought, other places. So all this, some sort of impact and effect will be there if we study the great detail into the atmospheric phenomena. Some study we have done into the black carbon, because we are studying at the Himalayan region, the glaciers, and understanding that how black carbon is impacting to the glacial names. And it is again obvious that if there is black carbon sitting on the glaciers, definitely they are absorbing heat, and if it absorbs heat, it will cause melting of the glaciers, even if there are some sort of impact of the global warming, plus extra effect it is doing. So like that we have to study.
Any other question? Quick question.
Quick question was, okay, well, just because this slide, so I was just wondering whether this is some kind of a general pattern for this thing?
No, the 3 hours time, 3 hours time in this particular specific region. If you do elsewhere, maybe it will be 2 hours, maybe 5 hours.
Yeah, yeah.
So we do not know the threshold. What I told in the beginning, that if we want to depend on the artificial intelligence and machine learning, it has to be taught. Again, human brain is needed. Without that, we have to taught that before reaching to the threshold only, he will give the warning. So he will understand that now it is going to reach the threshold. But if he doesn't know where is the threshold, then immediately he will give warning here. He will give warning somewhere here. So the threshold part, we still do not understand. This is very preliminary study we have made recently after the Dhaliganga Rishiganga, but we have to extend further. Your concern is very correct that it depends the geological, structural, area specific into that regions.
Yeah, just a quick question, very nice talk. Regarding the measurement of the platonic, you showed different plates, right? So how do you accurately measure this plate?
Yeah, you can measure. You have some idea on GPS.
Yeah. Like the satellite.
So what exactly happens? So just in a level language, I will tell you the plate movement, how you can do it. Even by stake also you can do some sort of stake in a region, and then you find out that stake at what position it is today, and then you make some using GPS. You can make measurement after some time, and then you can see that has been moved. So at what speed it has moved based on that in a simple language. But it has to be done by the satellite data. It cannot be done on the ground-based data.
Okay, if there are no further question, I have just one curiosity. I
Yeah.
cannot hear.
Should I go to
made
slide?
this, yeah, you made this kind of map, the risk map with the green and yellow.
This one,
Yeah,
this
this
one.
kind of.
Yeah.
So these, you said then, the people can use, depending on this thing, what to build up the houses and things like that. But to my understanding, this is not a static map, because this might change over the time.
Exactly.
So
So
how
periodically you have to
periodically
update.
it has
You have to
been
update.
revised.
You have to update.
And but this periodic thing, I mean, is this time sufficient? Someone builds a house and then demolishes it and builds
No.
somewhere else, or
Once you say this is a red zone,
Yeah, you don't build it there.
You
But
can't
we-
make it green, even if you.
No,
map
I
it.
understand, but the opposite can happen. I
Which one?
make something green.
This area,
and-
green
and
may happen.
then the house has to be demolished.
This house cannot be demolished. If you take care of now,
Okay.
then you need not demolish, because you are not allowing in the green, in this, you are
Yeah,
allowing
these are
over.
fine, but
You are allowing here.
right, right.
Then after few years, you are observing
Uh.
that something is happening over here.
That's good.
How do you expect that?
Yes.
Because no other factors is coming to play except the building load. So if you do not allow the building to be made up of some heavy materials, made up of some sort of more than these floors, or some of the resistant property into that material, then this region will not have any impact. You are constantly monitoring to this region by having the monitoring system. That landslide prone zone or any other avalanche prone zone, you are now developing monitoring system. So monitoring, when you are doing into that region, you will be able to know where you are getting some sort of change. Sudden change will not take place. Only you will be getting some sort of transition change.
It's a gradual
When you
thing.
find transition change, you give scientific cause why you didn't observe 10 years back.
Yes.
Now you have started. So you
Yes.
give reason. So
Yes.
because of the building, because of the something else.
Yes.
Then accordingly you have to take action. You need not break it, but you will be observing all these phenomena. That's what we are proposing.
Because the point is, as I can understand, there is a lot of, some society, some mindset is there of the Indians, whatever. Indians or in Himalaya, whatever.
No,
So
no,
you
no.
have to really get these into the people's mind.
If you have this map,
Yeah,
after 10 years, if you prepare this map,
yes.
then this life change.
Okay. So that
Unless-
time scale.
Unless this one is heavily occupied, that anthropogenic impact will be there onto that.
Okay.
Otherwise, it will be only slightly modified. We have prepared long back that seismogenic zone, that going zone, zone 2, zone 3, zone 4, zone 5. So if you look into the zone 2, zone 3, zone 4, zone 5, that map 30 years back, if you look into, and
Yes,
now
yes.
there will be maybe zone 5, somewhere it must have increased, zone 4 may be increased, or zone 2 have been decreased, like that slight phenomena. But you can understand why you are seeing that phenomena, then you can tell scientifically, because these things happen into this region, anthropogenic or any other thing, that you point out by doing some sort of research, and then you say that bhai abhi khatam ho gaya. Now you don't do further development like that.
Sir, is it related to plating? If it is
Which one?
this zone?
Which zone?
No.
This is landslides. I am not talking
Landslide.
of the seismic.
No,
Seismic duration time is different.
Seismic zone is the related to plate, right?
Plate movement is responsible for the accumulation of the stress
Yes.
beneath the surface, and the stress is the factor for causing earthquake. Whenever there will be earthquake, bigger earthquake, and number of earthquake, we call that seismicity. The seismicity is more means that zone is vulnerable to earthquake. We cannot say anything, but earthquake can also trigger landslides. Earthquake can also trigger. There will be some sort of cascading effects into the slope region. There is a lot of cascading effect. Earthquake, it can landslides. The landslides can block the river course. It can form the temporary lakes, and the lakes in course of time can be breached. It can catch floods. So many things cascading also we need to understand. It is not the one factor will be causing this purpose. That can lead to multiple things. We have to look into that as also.
We have to close the session.
Good that
Professor Sain, you might have to come one more time.
Yes.
So interesting.
Thank you that you people have understood